Hello, this is Brett from the W200 program, and recently from class these past few weeks we've been talking about computational thinking and how it can be applied in the classroom. Now me personally, I want to be a math teacher and specifically be teaching at the high school level, so I want to be a high school math teacher, teaching probably algebra or geometry as of right now. And computational thinking and algebra and geometry literally go hand in hand. Like computers and stuff, I'm going to try my best to draw a computer here, but they require numbers and complex programs, which is caused and created from mathematics, like plus, minus, times, divide. You get the picture. They go hand in hand, and because it produces and creates and promotes critical thinking skills and creative problem solving, which are aspects that are key in the development of students and their educational pursuits of knowledge as well. But there's actually, I wouldn't say issues, I'd say how are we going to promote computer science skills more in the classroom? Because some schools, like public schools or charter schools, may not have the resources, the complete resources, to fund all this. So we draw a little dollar sign here, sorry if it's blue, but they may not have enough dollar signs to fund into for computer science, and some of the software can be sort of taxing. This could be fixed if we can make convincing enough arguments as educational figures in the industry and the field to government officials to convince them that, because it's true, that teaching computer science skills would promote critical thinking and help promote a field of interest or a field of study that is desperately needed right now, as computer science and computers and technology as a whole is like massive right now. And because of the developments with engineering and computers and internet as a whole, we are like as far ahead in society as way farther ahead than our ancestors before us. And if we're going to continue that like development and growth into the future, more students having knowledge over computer science and more engineering type fields from the computer science programs in schools could like vastly improve and boost those occupations and the amount of people that are in there as well, which could be huge for the future, and also promote problem solving skills, which also makes even stronger students, not just in school but like outside of it as well. And the final part here, how would we implement that in the classroom with robots? Like I was talking about before, people in computer science and math, it all goes hand in hand. For example, if we're talking about Pythagorean theorem, for example, and we're trying to figure that out in a visual display, not just writing it on the board, we can have this robot here, for example, right here. We can program a robot to move in a specific way based off of variables from a Pythagorean theorem problem. Like, let's say, for example, there's a square right here, and we're trying to figure out which distance would be shorter. Okay, hold on, that'll be the question mark. 5, 3, and discovering how far of a distance this is from each other, and we can apply Pythagorean theorem. So 3 squared plus squared equals 5. It'd be 9 equals 25. Subtract 9 over. It'd be question mark squared equals 16, which would also equal 4. And they can use that and apply that knowledge with robots. It's a really important skill that could be heavily used in mathematics, and it also improves critical thinking skills, improves problem solving skills, and introduces new different fields of study that students may be interested in, and exploring those avenues would help improve the quality of life of education students, along with just the outside critical thinking and problem solving outside of school as well, which is also heavily important in the field of study and education.